All right, I'm going to see if I can produce a quick video on how to do what I want for this lab. So here we are, Q2, week 3, assignment 3, work to kinetic energy lab. What do we want to do? Well, I want to open up the CAMI directions here. In this lab, you'll use your fire extinguisher to do different amounts of work to astronaut Wally. For each Charlie to determine Wally's speed as he passes between the two photo gates that are 10 meters apart. You can control the mass of Wally, blah, 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 blah. We're over here. We're going to click begin. All right, so what does it say to do? It says start off with a 70 kilogram Wally, fly 70 kilogram Wally across the screen 3 times, keep the force constant. Try to turn off the fire extinguisher at the same location each time. Record Wally's displacement while the fire extinguisher is on, and record the photogate data to calculate Wally's final velocity. You can average the 3 times, convert milliseconds into seconds as needed, change Wally's mass to 90, change Wally's mass to 35, calculate the work and kinetic energy for each mass. So let's just run through this a little bit. I'm not going to do the whole lab. I'm going to show you what I mean here. So Wally's mass is 70. What else am I supposed to do? Keep the force constant. All right, why don't we just keep it at 115? We're going to activate. So the thing is you got to turn, so Wally's going to hit the fire extinguisher and it's going to push Wally with a constant force, which means an acceleration. When we have a net force, we have an acceleration, so a changing speed. We need to turn that off before we hit 70. Otherwise, we're going to be accelerating, and we want if we turn the acceleration or the force off before we hit 70, then we'll have a constant speed through this photogate timer with which we can actually calculate a speed, a final speed. So let's just hit activate. So here's Wally, just zooming across here. I'm going to go try I'm going to try to turn Wally off at 60 every time, like try to hit the same spot every time as near as possible. So what's the information I have here? Well, I have a mass of 70, so I guess I could just start a little new. Actually, I'm not going to do this on the CAMI document because then it's going to mess it up for everybody. I'll have to erase it. Anyways, I've got a mass. Let's write down what I have. Mass equals 70 kilograms. Force equals 115 newtons. So back over here, the photo gates are 10 meters apart, and the time it took to go from one photo gate to the next was the number of the beast. How convenient. Where's my untitled document? Let's drag that over here so I don't have to hunt around for it. So Wally flew however far that is. I have to estimate that. That's unfortunate. I'm going to go with like 63 meters. So Wally flew 63 meters. So that's the displacement I need for the work that's done, right? And then the speed of Wally is 10 meters divided by 0.666 seconds, because 666 milliseconds or 600.66 seconds. So 10 divided by 0.666, oops, I put too many sixes. Looks like it's going to be about 15 though, is equal to 15 meters per second. All right. So did I do what I was supposed to do? I don't know. The Wally, the turn it off at the same record the photogate data to get the final velocity. Then we're changing. And then down here, we're calculating the work and we're calculating the kinetic energy to see if they're the same. Is kind of the point to see that work and kinetic energy are related to each other. So the work is equal to 115 times 63, which is equal to 7,245, 7,245. And the kinetic energy, oops, is equal to 1/2, it's time for me to go, times the mass, which is 70, times the speed squared, which is 15, oops, squared, equals 0.5 times 70 times 15 squared is 780, 75, 78, 75. So you can see the numbers are not exactly the same. There's probably some error. So that's what I want you to do in the lab, I think, right? I gotta go get my phone. It's gonna bug my wife. And then we're gonna do a graph. And then we're gonna, how does changing the force affect the work? So we're gonna do the same thing, except now we're gonna keep the mass at 70 and set the force to 200 and 150. So we're gonna change the force this time. All right, I hope that helps.